So now let's have our first conceptual quiz. So this one will have the answers. So if we have the waves A and B overlap, so this is the concept of superposition. So we should try to add or subtract the amplitude. So based on the A, the first wave, B, the second wave, when they overlap at this particular moment, which one will be the result? So do you remember that in the second exam, I asked you a question about the superposition happens after 1.5 seconds. So when does the overlapping happens? It's very important. It changes the shape of the superposition of the two waves. So now these questions happen at this moment. So you just try to add the two amplitudes together. So when you are thinking about the answers, let's try to figure out. So the answer is C. So the best way to add the amplitude is that you can draw the dashed line like this. So apparently at this particular moment, there's still no overlapping between these two. So when you try to add amplitude, you simply just add individually to the flat place here. But for these two, they have overlapping between this range. So that's the reason here they will stay as the same, but in the middle they will be double because they are coherent. So you should add them, the amplitude together. So this is a concept of superposition, but be careful about when it does happens. Now I'm going to give you the second conceptual quiz, and this will be the first one which I'm not going to provide you answers. So if you have two wave with the phase given here, and they will have the interference, so what kind of the phase difference you can say about these two? So think about that. If you know the answers, please email me your answers with explanations. If you don't know, don't worry about that. On the Thursday, I will upload the lecture, so you can check the answer then. So now let's check the third conceptual quiz. So if you have the two light sources, emit a wave lambda equal to 1, in which are in phase. And now the two waves from the sources meet at some point. You don't know where it is, but now the information is given. The wave 1 will travel 2 meters to reach to that point, and wave 2 will travel 3 meters in order to reach there. So when the waves meet, they are out of phase or in phase. So this is a very important one, so I want you to think carefully before you answer that. So I want to give you a hint before I tell you the answer. So do you remember I told you that the difference of the path length is very important. So now what is the difference between these two path lengths? And you should try to compare this with the wavelengths you have. Okay, so this is very important. So therefore, the answer should be C, because the difference of the path length is 1 meter, which is 1 wavelength. So which means these two is out of phase for 1 whole wavelength. So you can say they're out of phase for 360 degrees, or you simply just say they are in phase. Okay? So this one out of phase by 180, you can say they are destructive interference. The same for these two, but you can find out that they are all destructive interference. Just how strong, how big the cancellation it will be. Now let's study the second topic today, and this is actually a very important experiment. We are going to use that result later when we try to study about the quantum physics. This is the so-called Young's double slit experiment. So in this experiment, you are going to provide a light source, and this light source, the only thing you have to make sure it is the monochromatic light, which they continuously provide the wave with the same wavelength. But this light source doesn't have to be coherent. So this light will then passing through some narrow slits. Okay, and you first pass through the single slit and now passing through the second slit. So the question is that what will be the result, the pattern you are going to observe here? So even though you probably already know the answer because I already showed you something, but I want to give you a discussion is that it depends on what kind of property of light it is. If light is a particle, like a photon we have introduced you before, then they are just two particles, yeah? So each of the source, the slits, is a one source of light. So particle will passing through the first one and the second one individually separate. They are not going to talk to each other. So if the light is a particles, what you are going to see in the final screen is just two thin strips. So you are going to simply see 1 and 2 here. But apparently you see more than 2 thin strips. So people start to argue that, okay, now the light is not a particles, it is a wave. If it is the wave, then each of the slit will serve as a new source. So now you can treat them, S1 is a first source and S2 is a second source. Each one of them will propagate outward as a wave, like what I just showed you here. So this is S1 and S2. So wave will propagate outward, and for sure during the propagation there will be interference happens. And now depending on where you stand in the space, you will find out in some regions it is a bright strip, some region it is dark strip. And this kind of wave property or explanation for the Young's double slit experiment is the so-called the Huygens principle. So until this moment, you will say that, okay, now we all agree based on the experiment, the light is made of wave. But later on, you will find out people doing something other experiment based on the light. They find out you cannot simply use the wave property to explain that. You need to use the particle properties to explain the light behavior. And this is a so-called the particle wave duality. And this is the most important step to understand the quantum physics. So we are going to use this one later. Come back to this experiment later. So for the Young's double slit experiment, what people will show is that if you only have one single slit, so which means this one doesn't exist, only this one exists. So you are going to see a pattern here. So this is one source of wave, yeah? So they propagate outward. So there is no interference because only one wavelength or one light source. But now if you have double slit, so you add this the plate here, so you have two light sources, S1, S2. So now all the constructive and the destructive interference I just introduced you will happen. So you will see a pattern of the bright dark streak. Okay, so this is the final result. You're going to observe the patterns, and for sure you can see the central one. The brightness is bigger, yeah, but it doesn't mean this is more important than the darker one. They are all equally important, but because now the bright strip here, because it is further away from the light source, so the intensity is weaker. So this is the Young's double slit experiment. So this is based on the data. So now let's try to study more about the math behind. So following the principle I just showed you, you have to calculate the difference of the path length. So depending on where you stand. So if you stand here, then it is a constructive interference, yeah? If you stand here for the dark fringe, then it is a destructive interference. So the path length, the difference of the path length is there's one from this source and the other one from this source. And now you stand in some position here and you will observe a light from the source 1 and 2. So you will find out if you are standing here, then the wave from the source 2 will propagate a distance d times sine theta further compared with the first source. So the difference of the path difference for these two is simply d sine theta. So what it is, if you try to use this triangle to compare, so d is the separation of the two sources, and this is the angle theta. So theta is not given, it depends on the province. So if you know the separation of the angle, and if you are given how to find out the theta, then you can calculate the side. This is the sine theta, d sine theta. But even in the case, you don't know it is a constructive or destructive. This is just the path difference. So therefore, the condition for the bright fringe, which is the constructed interference, is that the path difference is an integer number of the wavelengths. So n will be from 0, positive 1, 2, 3, or negative 1 or 2, 3. So in this direction, it is positive, and in this direction, it is negative. Okay? So this is how you check the condition for the bright fringe. So not a surprise to you, for the dark fringe, the path difference is still the same. And please remember that this figure is for the observer at this point, okay? But the result is in general true, no matter you're standing here or here. So the condition for the dark fringe, which is the destructive interference, is the difference equals to the half of the wavelengths, or 3 times the half of the wavelengths, 5 times the half of wavelengths. So m is still from 0, 1 to 3, but you will find out it is not actually the integer of the wavelengths. It is a half integer of the wavelengths. Now you know the condition for the dark and the bright fringe. Now we can study what we just see later. So if you have 2 double slit, the light will propagate through and they will behave like a 2-wave source. And they will have the interference. And now at the position, the central position here, m equal to 0, this is the position they have the equal distance to the S1 and S2. So apparently this will be the position for the bright fringe. This is so-called the central bright fringe, and the notation we're going to use is m equal to 0. So if you use m equal to 0, you will find out this is the case. Then this is the brightest one you are going to observe here, center. And now the one next to the first bright fringe, it will be the first dark fringe. So it could be m equal to positive 1 or m equal to 0. So if you substitute 1 into the formula here, it is the positive 1/2. Yeah? If you substitute 0 here, it is negative 1/2. So this is the adjacent, the dark fringe, which you are going to observe here, the dark fringe next to the central bright one. And now the pattern simply just repeat. So you are going to find out the second bright fringe, the third one, and you can go upward and downward. The pattern should be symmetric as long as the plate here is also symmetric. So now you can compare these figures with the result you're going to observe from the experiment. And now you will find out the notation here will give you a very important information. So for the bright fringe, this is 0, so at the center. But now for m equal to positive 1 or 0, actually they are symmetric. Okay? So now let's have another conceptual quiz. So in a double slit experiment, when the wavelength of the light is increased, the interference pattern will happen what? So this is a little bit tricky, so think about that carefully. So the answer is it will spread out, and I will give you the explanation in the next video lectures.